There are some very common uses of for loops. One thing we could do is we could have input from the user. For example, if we wanted to prompt the user 5 times for a value, then we could do that in a for loop. And then we could use the actual value that the user entered, or we could just echo print it. Another thing we could do is we could iterate through the elements of a vector. For example, if we want to read into elements of the vector, so if we want to prompt the user and actually store the values that the user enters into a vector, then we could do that using a for loop. In many languages, it's necessary to perform operations on vectors, but not in MATLAB. So if you want to read into elements of a vector, you would use a for loop in MATLAB. But if you just wanted to perform some operation on all of the elements in a vector, you would not normally need to use a for loop in MATLAB. You would in other languages, but in MATLAB, we can use the built-in functions and operators. We could also calculate a sum. For example, we could initialize a running sum variable to 0, and then we could loop to add more and more values to this running sum. Or we could calculate a running product. To do that, we would initialize a running product variable to 1, and then we'd multiply more and more values to this running product. So if we wanted to repeat the process of prompting the user and reading values in a specified number of times, we would use a for loop. So let's say that we have an integer n, and we want to repeat the action n times. So I might have a for loop that says for I gets the value of 1 colon n. So we're repeating the process n times, and as the comments say, in the action of the for loop, what we're going to do is to prompt the user and read in a value, and then presumably actually do something with it. So n times we're going to repeat the process of prompting the user, reading something in, and then doing something with the value that the user entered. If we wanted to repeat the process of prompting the user and reading into elements of a vector, we can use a for loop to that. And the loop variable is used to index into the vector, so that's very important. So our for loop says for I gets the value of 1 colon n, so we're going to repeat the process n times. And what we're going to do n times is we're going to prompt the user and read in a value. So we're going to prompt the user, say enter a number, and we're going to read the value and store it in the next element in the vector, vec sub I. So that's very important, is that we're using the loop variable I to index into the vector. So the first time in the loop, when I has a value 1, we're reading into vec sub 1. Then the next time through the loop, when I has a value 2, we're reading into vec sub 2, and so forth. And then presumably, again, once we have the value in the vector, we would do something with it. But again, very important that we're using the loop variable I to index into the vector. So just as written here, this code would keep extending the vector one element at a time, which is very inefficient. So what we really should do before we start this loop, since we know that the vector is going to have n elements altogether, is we should pre-allocate the vector to have n elements to begin with, so that we're not extending the vector. Instead, what we're doing is just changing each element in the vector. So pre-allocating a vector sets aside enough memory for the vector. So it allocates enough elements in the vector. The alternative, extending a vector, is very inefficient, because what happens is that every time MATLAB has to find new memory and copy the values that were in the existing elements and then add another element. That's extremely inefficient. So a lot of functions could be used to pre-allocate, although it's very common to use the zeros function. So for example, if we want to pre-allocate a vector vec to have n elements, we would start by creating the vector before the loop by saying vec gets a value of zeros, 1 colon n. So now vec is a vector that has n zeros in it. And then we would have our for loop, in which we're prompting the user and reading into each element in the vector. So now what we're doing is changing each element in the vector from 0 to whatever the user enters. So that's a lot more efficient than extending the vector one element at a time. Again, in most languages, operations on vectors are accomplished using for loops. In MATLAB, instead, we use the built-in functions and operators, and this is called vectorizing. So this term vectorizing basically means getting rid of loops. So loops that you would have to write in another language, you don't have to write in MATLAB, and so vectorizing the code means getting rid of those loops, using the built-in operators and functions. So for example, if you wanted to sum all of the elements in a vector, you could use a loop, start a running sum at 0, and keep adding each element from the vector to our running sum. But in MATLAB, we don't have to do that. We just use the built-in function sum. So MATLAB has lots of useful functions that do things like this, for which you'd have to write for loops in other languages. So other functions include prod, that will give you the product of all the elements in a vector, the cumulative sum and cumulative product functions that will give you the running sums or the running products, and the min function, which will give you the minimum value in a vector, and max, which will give you the maximum value.